think it's working.
Can you hear us?
We'll stand next to each other this time. Good?
Good to go.
Okay. Good morning. We are the Quadcopter team. My name is Kim-Thu Pham.
I'm Justin.
I'm Ivan.
So the motivation for our project is to create a remote data sensing system where we use a UAV to go out into the field and gather data. And our solution was a quadcopter, and then a lot of nodes that were solar powered to conserve as much energy as possible. And then we use Bluetooth low energy communication between the quadcopter and the nodes.
So this is an overview of our system. Most of the sensors, except for the humidity and temperature sensor, are communicating to a PSOC4 BLE beacon that is set on the ground over ADC, and then the humidity and temperature sensor communicates over I2C. The beacon itself will store and read memory to flash, and then once it connects to the receiver, which is the drone, over Bluetooth, then it will read the memory from flash and send all the data over to the receiver. From there, the PSOC4 receiver will send over all the data to the PSOC5 through UART, in which turn it will store all the data into an SD card over SPI.
We designed a beacon that uses a power management IC from Cypress. It's able to choose between a solar cell or a battery input, and depending on the resistors, could also set the output voltage to power up the system. The beacon has the sensors, the temperature, moisture, humidity, and the light. It should have a flash memory that could store all this data, and so that the drone wouldn't need to go acquire the data frequently. It has a rotary switch for the user to manually change the address of the beacons, and a PSOC4 for puts communication. The receiver has a PSOC4 BLE, a PSOC5, and an SD card. The PSOC4 is to get the data from the beacon, and PSOC5 to store the data to the SD card. The PSOC5 communicates with the Intel Edison with the flight controller of the drone to tell it when to stop or to go.
Okay, so we ran a field test and these were our results. So we were able to confirm that the receiver was successfully connecting to all of the beacons and be able to tell the difference between them. Then we were able to see that data was collected and that all of it was coming from the right sensors. And then we also saw that our energy management solution worked because our solar panels on their own were able to power up our system. So that was a huge accomplishment for us in terms of low power. Then we calculated the total cost in the end, and the cost of a beacon is $67 and the receiver is $42. So this is a lot cheaper than what you can see in industry where they charge like $20,000 for an agricultural solution. But what we have right now is very cheap. So yes, you can see below that we've gathered data and put it into a notepad format document, and it marks all the times and all of the data that we need. And this is our video. You don't really press YouTube. Click YouTube, and it will show up.
Just check this video if it will work. Not my fault. Alright, so good. This one there?
Oh, hey, loaded. Yeah.
Yay! A project is a data gathering system that uses a quadcopter to bring wireless communication to sensors in the field. Here's an overview of our system functionality. Let's start with an example flight over Hutchinson Field on the UC Davis campus. A quadcopter will follow instructions for an automated flight. No manual control is needed except running the program. First, the quadcopter does an automatic takeoff from the starting point and begins to travel to the first beacon. Here, it reaches the first beacon and detects the beacon's Bluetooth signal. Once a connection is established, the beacon sends data to the receiver. After the data transfer is complete, the quadcopter continues its flight. The quadcopter flies over the remaining points and gathers the data at each one. Then, the quadcopter returns home and lands. Our data gathering system uses technology from Cypress semiconductors. This is our beacon. It uses a PSOC4 to control sensors, memory storage, and Bluetooth communication. It also uses a power... C from Cypress that manages inputs from batteries and solar
We're
panels.
gonna let this buffer and all these buffer.
Yeah, just let them all buffer probably.
Guys are killing me. Blame the internet. It's focused. It's focused.
8 minutes, that works.
Oh, it does? Okay, sweet.
I can't listen.
Yeah, thought they were, yeah.
What are we doing now? I'm loading all the videos. Thank you, presentation. It's not, it's still loading. It's still loading.
Okay. They're all gonna load really slowly.
They're gonna give me the raw file today. Okay, we give you after this is done. He's pre-recorded the videos. Is it raw?
Our videos are
Okay. Okay.
In the meantime,
So
do
what
you
I'm
want us
telling
to, okay.
Nick is that I'm in the process of writing a very large proposal in the area of agricultural sensors using Bluetooth and so forth. So be able to show, not that you guys are not doing good things, it's just that this one maps directly onto a much larger theme. It's a collaboration between people from Davis, from University of Michigan, University of Illinois, connecting with the visualization that Ma's doing. And its proposal is going to go in next week. And so being able to show this type of work is really very helpful. Thank you. Go ahead.
Oh, in the meantime, if it's not, oh, it's ready, okay.
This is our receiver. It uses a PSOC4 for Bluetooth communication and a PSOC5 to store data and communicate with the flight controller. Now let's see all of these components work together in a real experiment. We place beacons in the hallways spaced far apart. Now we start up the quadcopter and the receiver. Note that we have no propellers on the quadcopter right now. As we walk down the hall, the receiver will connect to each of the beacons in order. Here's the data we got from the experiment. From the flight controller output, we can see that the receiver connected with all the beacons. Now we unload the SD card. You can see the data from moisture, humidity, temperature, and ambient light, as expected. We would like to thank Professor Knosen and Cypress for sponsoring our project. We would also like to thank Jonathan Mars for being our project mentor.
Any questions?
Questions?